Work problems and quadratic equations. Once again, we've actually done these work problems before in the past, so if you need to refresh yourself, you should go back to those rational equation problems that we were doing with work problems for more, if you feel like you need a refresher on how to set these problems up, but I'll do a little bit of a review here. So work problems you'll remember. So let me read the example first. Discover Magazine needs to produce magazines faster than usual for certain special issues. So they have press number 1, which is quite a bit older, and it takes 12 hours to do the job. Or sorry, 12 hours longer to do the job than press 2 could do on its own. But we're told that working together, the two presses can complete one printing in 8 hours, and we need to calculate the print time of each individual press. So just as a reminder of these work problems, what adds together when two people who could do a certain job in a certain amount of time independently, when they work together, what adds is the rate that they can complete a job at. The rate to complete a job. Adds together. That's the key in these work problems. And there's a couple of assumptions that we're going to need to make with these work problems. So first is that in this one in particular, each press can print independently. So that each can complete the magazines independently, that press 1 doesn't need to wait on press 2 for anything, or that press 2 needs to wait on press 1, and that the presses can run as long as they need to, i.e. they don't need to, or they don't overheat or need to shut down, or that they jam and you need to repair those things. So we're making some assumptions that these presses work perfectly, even though one might be slower, but that they work perfectly, that they don't have those sorts of hiccups. So let's talk about work problems very quickly. So we mentioned that the rates add. So if someone can wash a car in 30 minutes and someone else can wash a car in 15 minutes, obviously the two of them don't take 45 minutes to complete a car. They should do it faster than 15 minutes. So what adds is the rate that each can complete the job at. And rates are a thing in a certain amount of time. So what we're adding here is one printing per time to complete. That's what's adding. Now we have two printers which are combining together. So that would be the rate of press 1 plus the rate of press number 2 combines together for the combined rate. Now the combined rate we know. We know in this problem we're told that they can complete one printing together. The two presses can complete one printing in 8 hours. So that means that one printing can be done in 8 hours. I don't want to write my units of hours in there because we're not going to need them when we go to solve the equation. But I could if I wanted to, just so that we know where that 8 came from, 8 hours. And now we have these other two rates. And how are we going to write these other two rates? The key is to use the relationship that they have to each other. We're told that press 1 is quite a bit older and takes 12 hours longer to do the job. So what we have to do is we have to define one of the times to complete as just a variable. So we're going to say that the time for press number 2 equals t. And I do my t's with a little curl on them so that I can keep them separate from my plus signs. So that's what that little curl is at the end. So what that means is that the time for press 2, or I should say the rate for press 2, is 1 per t. And the time for press 1 is 1 and then t plus an additional 12 hours. And now I have an equation, a rational equation, that I can solve using my rational equation skills, and we're going to find that it also requires some quadratic equation skills. So this is what that looks like. Now I'm going to start this equation fresh on another slide here. So this equation is 1 over t plus 12 plus 1 over t equals 1 over 8. And to solve, I have to multiply everything by 8t times t plus 12 to get rid of all those denominators. So multiplying that into each of the 3 terms in the equation, that would be 8t plus 8 times t plus 12 equals t times t plus 12. And now we'll expand and we will solve. So that's 8t, doesn't need any expanding. 8t plus 8 times 12 is 8 times 12 is 96. And then t squared plus 12t. And let's move everything over to the left-hand side. So this would be 0 equals t squared. I have 12t minus 8 is minus 4t, and then minus 96 over there on the left. And hopefully this is factorable. Let's see. Can I find factors of 96 just by guessing? Oh, I got lucky early. I tried 96 divided by 12, and that's 8 and 12. So if I do negative 12, positive 8, I get negative 4. So sure enough, 0 is equal to t plus 8 times t plus 12, or sorry, t minus 12. So that would be that the time for press 2 to complete is either negative 8 or positive 12. And as usual, we're going to reject negative times. Negative solutions don't make a lot of sense in these sorts of problems. Sometimes they will, but sometimes they don't. Most of the time they don't. Which means that the time for press 2 is 12 hours, and the time for press 1 is 12 plus 12 is 24 hours. Keep in mind that original question, we were asked, calculate the print time for each individual press. So don't just write t equals 12. That's not a complete answer. Make sure you answer the question that's asked of you at the beginning.